Good. So now, the symbols got their start with the alchemist. Okay, you may have read that book, The Alchemist. The alchemists are the, precursors to today chemists. They've given us many of the techniques that we use in chemistry, such as distillation, and a lot of the laboratory procedures that are used even today. However, if you read Harry Potter, and you remember hearing about Flamel, who was actually a real person, they were trying to discover a way to turn base metals, like lead, into gold. As far as we know, they've never were successful at that. Okay, this is called transmutation, which actually can be done today, but in a very different way. So what happened when John Dalton came along, who we're going to talk a little bit more about in the next unit, they started making symbols. Now, some of these symbols that we have here are not similar to what we use today. We have what I showed you on the previous page. So sometimes you'll see written some of these other symbols representing common elements. Okay, the person who created today's symbols was Jöns Jacob Berzelius. He was Swedish. And he based his symbols on pretty much the Latin names of the elements, which also correspond, most of the names are also used in English. Okay? Because some of the names, like oxygen, was discovered by Lavoisier, and he probably wrote it out in French. So, as we said previously, the chemical symbol is one or two letters. First letter is always capitalized, second letter is lowercase. And for the most part, most of the names in the periodic table correspond to what we call the English names. The few that do not will be derived from Latin, German, or Greek. So these are the Latin ones, okay? And you're probably familiar with this. Okay, so sodium was originally called natrium, potassium was called kalium, and that's why we don't have, this is one of the things people always mess up when they write down sodium. S is for sulfur, okay? Na is for sodium. Potassium is K, comes from kalium. This one I like to remember because the SB, because if you studied in history, the women's rights movement, you might have studied Susan B. Anthony. So Susan B. Antimony is the way to remember antimony symbol, which comes from the Latin word stibium. Copper is Cu because the Latin word was cupra. Gold is Au for aurum. If you speak one of the Romance languages, especially in Spanish or Italian, oro would be gold, okay? So it comes from the word for gold. Now, silver is Ag. Now, one of the ways to remember silver's name is to think of the history of a country in South America. This country's major city is on the Rio Plata. What does plata mean in Spanish? Okay, if you said silver or change or coin, you'd be right. But in Latin, silver is argentum. And what happened is, when the Spanish controlled that area of the world, they would go up the Rio Plata, all the ways up through Paraguay, up into the mountains, where they had silver mines. And they would bring that down, the River Plata, because it brought the silver from the mountains down to Buenos Aires. And from Buenos Aires, it would go back to Spain. So the country became Argentina because That's where the silver came from. Okay, iron, ferrum. Okay, again, you might have heard of hardware stores all through Miami. Ferreteria. Okay, that means what? Nails or screws are often called that. So they're made out of iron. Another one that you might be familiar with is lead. Before we had PVC or copper plate pipes in our houses, they used to use lead pipes. And lead was used for the plumbum. Okay? Now, there's some thought that in Romans times that what happened, part of the fall of the Roman Empire, was people were getting lead poisoning from the lead leaching into the water supply from the lead pipes that the water came into their houses from. And finally, tin is stannum, SN. If you look on Colgate or some of the other products, you'll see contains stannous fluoride. That's the Latin name for tin. Two other ones that aren't on this list are the Greek word for mercury, and that is Hg, and that comes from hydro, Okay, now hydrogyrum is water, flowing water, okay, or flowing silver. Sometimes this is called quicksilver, okay, because it looks like silver, but it's quick because it's liquid. And the other one I'll put up here is W, okay, which is tungsten. Okay, tungsten, and that's because it comes from German, and that was called Wolfram. Okay, so that's some of the words that are not that easy to remember from the symbols. Okay, chemical symbols provide a shorthand way to write the chemical formulas. For instance, we've been talking during this video about water. Again, 2 hydrogens per 1 oxygen to make water, or sucrose, there's 12 carbons, 22 hydrogens, and 11 oxygens in table sugar. Okay, so a chemical formula allows us to write, instead of the name, or instead of saying 12 carbons, 22 hydrogens, and 11 oxygens, writing that out, we're able to just write the symbols with a number, tell us how many, the ratio between the elements in the compound. Okay, so those numbers in the subscript basically tell us the ratio of the previous element to the one that follows. So, for instance, water is H2O, hydrogen peroxide, which is another compound of hydrogen and oxygen, is H2O2. So there's a 1-to-1 ratio. Okay. Now, one of the reasons we usually would just write that HO, because you would cross that out, but this is unusual because peroxide has a unique characteristics. Okay, so a formula for a compound does not change. If it changes, it's a different compound. Okay, so what languages are represented for chemical symbols? Okay, most of them are English. Okay, they are also, quite a few of them are Latin, but some are German and some are Greek. Okay, let's talk about the periodic table. What does the periodic table do for us? Well, it organizes the elements into elements that are similar in properties. that appear on a repeating basis. Okay? So, when we look at the periodic table, the reason it's not just one big long line, the places or the columns that everything are in are called groups or families. And we call them families because they have similarities, because these properties repeat throughout the family. So the periodic table allows you to compare different properties of different groups because the chemistry of the elements in each group will be similar to those in the same group. So if we look at it, the thing lithium, sodium, potassium, rubidium, cesium, and francium are all in the same family. Now if you look, hydrogen is up here, but there's a big white space there. That's telling us hydrogen is alone. Because it only has one electron and one proton, it has its own special chemistry. We put it here because all of these have one electron in their outer energy level, but hydrogen doesn't perform like these. It's totally different. There's what I said earlier, our three letters. They are unnamed elements. So how does the periodic table work? The elements are in a certain order, and they go from left to right, and then they return back, and they go from left to right, increasing order. Okay, depending on the type of periodic table we have, in this one, the number above the symbol is its atomic number. Okay, so in this picture, on the previous slide, the atomic number was centered above the symbol. This isn't always the case on every periodic table. Sometimes they'll have more information. But if the number is sequential, so the element before it is one number less, and the element after it is one number more, then we're talking about the atomic number. Okay, so hydrogen is in the upper left corner, helium is up on the upper right, then lithium starts the second row with number 3. Now what do we call the horizontal rows? We call them periods. So rows are period, and there's 7 of them. And the number can range from 2 from the first period up to 32 in the 6th period. So as you go across a period, properties of the elements will vary and will be different from each other. And at a certain point, when you repeat, the same properties will repeat in the same order. So I mentioned each vertical column is called a group or family because they have similar chemical and physical properties. This is something that is sometimes shown and sometimes not. Today we usually look at the periodic table and go 1 through 18, and previously we had, let me go back to the periodic table and show you. Okay, we have here, if you look, 1A, 2A, 3A, 4A, 5A, 6A, 7A, 8A. The ones that are A's are what we call our main group elements. The B's are our transition elements. However, on many modern periodic tables, they simply just call it 1 through 18. And so that you don't have the A's. But both are still used today, so it's good to see it this way too. All right. This should be an easy question. Yes, all known elements are included in the periodic table. Okay, now for review. Compounds can be broken down into simpler substances by chemical means, but elements cannot. Composition of a material is fixed. Material is a substance. If the composition may vary, the material is a mixture. Chemists use chemical symbols to represent elements and chemical formulas to represent compounds. The periodic table allows you to easily compare the properties of one element or group of elements to another element or group of elements. Here are the vocabulary terms you should know. Turn off the video, take these down in OneNote. Turn off the video, take these down in OneNote. And our big ideas. Matter can be made of elements or compounds. Elements and compounds are pure substances, but can be physically combined to make heterogeneous or homogeneous mixtures, and these different forms of matter may undergo physical or chemical changes. That's it. See you in class.